Welcome to Cow Talks. This is Marcelo Wallau, Forage Extension Specialist with the University of Florida. And this is our podcast, where we dive into the main topics affecting livestock and forage production in the southeastern United States. Join us in this journey as we tackle the main issues affecting our producers and the sustainability of our production systems. Hello and welcome to Cow Talks. This is Marcelo Wallau, Forage Extension Specialist and Associate Program Leader at the University of Florida. My guest today is Dr. Shelby Gruss. She's an assistant professor and my counterpart, Forage Extension Specialist at Iowa State University. We're here today to talk about nitrate toxicity and prussic acid poisoning, a topic that often gets very popular in the fall time of the year. We got a lot of questions about those two things, and Shelby has a lot of experience about that. That's why we're here to discuss what it is, how it comes about, what are the strategies to manage, and what do you need to know about those two problems with some of our forages, prussic acid and nitrate. Shelby, welcome.
Thank you for having me today.
Talk about nitrate toxicity. We talk about prussic acid together as if we're one thing. What is that, and why are we so interested in talking about that in the fall time of the year?
So prussic acid and nitrates, they are not the same thing. So we do kind of have to start thinking about them separately, but we generally get them lumped together because of the sorghum species. Sorghum is one of the common warm season annuals that we use, and it can accumulate nitrates or prussic acid potential. And so a lot of times I hear a lot about prussic acid in the fall because everybody's concerned about a fall frost. And past research and a lot of extension has kind of seen that a fall frost could accumulate prussic acid potential. Nitrates, I feel like they get lumped into getting talked about in the fall because we're talking about it in the sorghum species. Where nitrates, I'm actually more concerned about nitrate toxicity when I overapply nitrogen and after a drought period, right? When all that nitrate's getting uptake into the plant.
I want to understand a little bit more what is the nitrate toxicity, what is causing it in the animals, and how can we see that in the animals? So can we decompose the nitrate toxicity problem for our listeners?
So a lot of times nitrates, when we think about nitrates, they come in and it's basically a usable form of nitrogen for the plant. And so they accumulate at the base of the plant. A lot of times they come in the lower stems. And so it starts to accumulate there. And when we start to see it in the animal, basically the animal can detoxify a little bit. But as we get higher levels of nitrates in the animal, what occurs, hemoglobin changes to methaglobin. And so the animal can't carry oxygen. And so what happens is the animal starts to go through very actual similar to what prussic acid does is basically the animal can go through convulsions, tremors, staggering, and death very, very quickly. In either case, it's not really suffocation in the same manner, but that's how I kind of think about it.
Lack of oxygen for the cell. So the blood is really not bringing that. And we can notice that in the animals with a very brown color blood, right?
Yeah, so you start getting that chocolate colored blood in the animal when you start to see nitrate toxicities.
So, okay, let's separate them to talk about. Nitrates can occur in pretty much any forage species, right?
Yeah, nitrates can occur in so many different forage species. I just feel like every time sorghum gets brought up, nitrates and prussic acid are very quick to follow. And those are two of the most common questions I get when people are starting to use the sorghum species. But it can occur in almost really any type of forages. I think about cereal grains now that are getting more commonly used. Cool, cloudy days. The plant's not photosynthesizing as much, and so it's not utilizing the nitrogen that it's uptaking. And so there's a lot of different forage species that can accumulate nitrates. But I feel like our warm season annuals are notorious for it.
Perfect. And it can happen at any time of the year for the nitrates, correct?
Yes, it can happen any time of the year for the nitrates. A lot of times when we talk about it here in Iowa, it's because of two reasons. We are using a corn nitrogen rate on our warm seasons. And so a lot of times we're over applying nitrogen. And so we need to give it longer for that sorghum species to be able to utilize it or that warm season annual. And also right after a drought, when we apply nitrogen and then we go in drought period, and the plant is not utilizing that nitrogen yet because we don't have the water for it to be uptake. Right after that drought gets broken with a rainfall, a lot of nitrogen gets uptaken by that plant. And so a lot of times we want to wait before we start utilizing that plant after a rain breaking drought.
So is there any number that we normally are start being concerned. Fertilization beyond this certain pounds per acre of nitrogen is where we start seeing a lot more potential nitrate problem.
Yeah, and so I think it depends how it's being used. So a lot of times our longer season sorghum, we can start to apply more nitrogen because it has a longer period. So like if we're using it for silage, I gotta admit, I cannot think of the number on the top of my head, that specific value, but a lot of times we can apply more at that point in time, where if we're starting to graze it, we're going to be using it earlier. And so we're not going to want to apply as much right away, where a lot of times we could do that in a split application where we apply some right at the start, and then after they graze, help it to regrow. But we're not applying, say, 100 pounds per acre during that split application each time, because that's going to start to overwhelm the plants.
Mm-hmm.
A lot of times people like to think about it in number of days to the amount of nitrogen that's applied. So if you have 200-day growing season for your sorghum, then you could probably apply 200 pounds of nitrogen to be able for that plant to utilize it. Now, if you have a 90-day growing season, you'd want to apply 90 pounds. It's kind of the general rule of thumb, I guess, is the best way to put it. So trying to keep it so that we have plenty of time for the plant to utilize the nitrogen it's uptaking.
Fantastic. Yeah. I normally tell our farmers here that most of the times we're under applying nitrogen.
Mm-hmm.
So nitrate's seldom a problem. Normally is, or we're quite not there yet.
I think that's a great point, though, because we're generally under applying, but also sorghum species don't need as much nitrogen as some of the other crops that we use, like corn. And we're just so used to corn here in Iowa that we mimic what we do there.
For us, it's a little bit different. We're so used to Bahia grass that we put very little nitrogen. And when people say like, well, we're putting 80 pounds split, like, good, like, let's go.
Yes.
So can we jump into the Prussic acid a little bit? So kind of defining what that Prussic acid is and the big difference between those two problems.
So Prussic acid, the difference between that and nitrates is an occurrence when it accumulates in nitrogen. Prussic acid is a natural secondary byproduct that sorghum species create from a compound called durin. And so the sorghum species plants create durin. And then when durin breaks down, it releases hydrogen cyanide or prussic acid. And so it's called a cyanogenetic glucoside. And one thing that we'd never really talk about is there's thousands of species out there that create cyanogenetic glucosides. So a lot of times we talk about prussic acid, sometimes you'll hear about, let's trim your cherry trees to make sure they're not overgrowing the fence, because that also can create prussic acid and animals chewing on it. And so two of the big things that I always think about when I'm thinking about the difference between prussic acid and nitrates is nitrates accumulates in the lower stems, where prussic acid generally accumulates in the upper part of the plant and in the leaves. And so a lot of times it's a little bit opposite of how you would think where they are occurring at. The plant naturally does it, while an external factor has to come in to help the plant accumulate in nitrates. Is kind of how two ways that I think of them as different.
And so we have the trigger for the nitrate. We have it's normally a sequence of high fertilization levels with stress.
Mm-hmm. Yes, correct.
The prussic acid is going to be stress that damages tissue, right?
Yes and no. So The plant actually produces it naturally when it's really young as seedlings. We think it's a defense mechanism. So the plant doesn't have to be stressed in those situations to be accumulating high levels of prussic acid potential. And so a lot of times you'll hear a recommendation, do not graze your plants until they're 18 to 24 inches tall. And that's to allow the plant to mature more and for that prussic acid potential to dilute as the plant gets older. And then the secondary factor is that stress comment that you just made. So as the plant gets more mature, it declines in prussic acid potential, but it can increase again later on. And that's why we get these calls in the fall. And so one of the big things that is interesting is as the plant gets frosted, the plant goes under a stress period by being frosted, and the living tissue can respond by increasing in durin concentrations. It's actually kind of interesting. I feel like if you go back in the literature, it's a little bit back and forth depending on if you see an increase or if you don't see an increase. And I think that has to do with the part of the plant that died. It doesn't have an ability to respond, where the living tissue has the ability still to respond. And so some of the work I did during my PhD we tested the green tissue left of the plant, nothing that had died. And we did see this response of during accumulation. And so when during accumulates, that increases that prussic acid potential.
Very interesting. I heard something recently in another podcast show talking about prussic acid, about the grazing the stover of regrowth of sorghums. Is there a problem of high concentrations of diarrhea in leading to hydrogen cyanide in regrowth of sorghum when it's harvested for grain?
Yes. So as the sorghum starts to regrow, the new shoots can have high concentrations of prussic acid potential as well. And particularly grain sorghum. If we were to start ranking the species of sorghum, grain sorghum is our essentially highest prussic acid potential. And then it's forage sorghum, so stuff we're using for silage, sorghum Sudan grass, and then Sudan grass is the lowest prussic acid potential. And so we got to be careful with that regrowth of those plants. And particularly if we're thinking of how animals graze, they like to graze the green things first.
Yep.
And so if we have a lot of tillers out in the field or shoots coming up, they could be selectively grazing that over the stover that was left from the grain harvest. So it can be very careful in those situations.
Interesting. I'm just thinking that we don't have a lot of grain sorghum here grown in Florida, but we have forage sorghum. A lot of it harvested for silage, which is a different production system.
Yes.
But those that are grazing, the fact of not grazing it down to the ground, not grazing it too low, then we avoid the nitrate because of the lower stems, and also we avoid some of that potential concentration of diarrhea in the plant when we graze it too low.
And I think that's a great point, because like I always think about nitrates and prussic acid. Nitrates, when I think about grazing, as long as you don't graze too low and you're allowing them to pick the leaves over the stems, it's not as much of a concern in comparison when you're thinking of prussic acid.
You didn't mention one of the biggest culprits of nitrate poisoning here, I believe, in the southeast would be Johnson grass, especially when we're short of forage. Actually, prussic acid poisoning too. Short of forage, that's the only thing green in the fall. Cattle get in there.
Luckily, we don't have as much Johnson grass here in Iowa yet. I have seen it. I've seen shatter cane around too. We got to be aware of the wild species or the weed species that are around. Johnson grass is a high accumulator of prussic acid and can of nitrates as well. So knowing that is there is very important. And Johnson grass can grow in such a sod almost because of the rhizomes. And so they get in there, that's all they're grazing. And so it can be really high in those concentrations.
Yeah. So we talked about the nitrate toxicity with the oxygen. So the metaglobin, lack of oxygen to the cells, leading to that dark color, like brown blood, chocolate blood. In animals, we can see animals panting because of that lack of oxygen and all that. What do we see on the prussic acid poisoning in terms of the cause and then the symptoms in the animal?
So the cause is basically the cell itself can't utilize the oxygen. It inhibits the electron transport chain, basically not being able to create energy. And so it is actually interesting. The way we help identify it is we have cherry red blood, because the blood has a ton of oxygen, it's oxygenated, but it can't be utilized when it gets to the cell. And so with that, it's again not being able to utilize oxygen. So the symptoms of the cattle are very, very similar. We're seeing that gasping for breath, that staggering, death very, very quickly in severe cases. And so the big difference is all the nitrates and prussic acid, the symptoms of the cattle are the same. It's really, you got to go in and start looking at the blood to really tell the difference. Yes.
Awesome. So we're able to kind of define them two different issues here. They're not the same. The only common thing is that most often we see them mostly on sorghum species in terms of forages. Symptoms are very similar, with the difference here and there, what is causing. And then on the management side, we also have quite kind of similar strategies, correct?
Yeah, a lot of our management's pretty similar between the two. The big difference in the management is when we talk about grazing, which I've already mentioned, is animals are going to selectively graze the leaves. So prussic acid is going to be a little bit higher of a risk than nitrates in those cases. And so then when we think about silage is a really beneficial management strategy. In both cases, it can reduce prussic acid potential and nitrates. One of the concerns in nitrates is if nitrates are high enough, it may not reduce it enough. And so if you have super high concentrations of nitrates, we still need to be careful to ensure that we did get the reduction that we're looking for. And then if we didn't, we need to be really thinking about diluting feed and things like that to ensure safety.
We normally see nitrate problems with hay production here. Actually, we do what we call the Southeastern Hay Contest, and nitrate is one of the criteria for elimination. So if we have any hay that is, I think, is above 5,000 ppm of nitrates, you're out, because that's a hay that is a very high risk nitrate toxicity.
Yeah, and when you get that high, it's even hard to dilute. You're looking at a considerable amount of dilution before you can start feeding that safely.
Correct. So if we're starting looking at we can pick sorghum here, but it also could be for some other grass, especially if we consider nitrate. If we're starting the season, can we go into the management? So first of all, 18 to 24 inches is the minimum height before we can graze sorghum, correct?
Correct. We're making sure that that plant can dilute out the prussic acid. If you're looking at, say, a pearl millet, that recommendation is not necessary, just because
Correct.
pearl millet does not have the prussic acid concerns.
Perfect. Well, early in the season, we're going to start fertilizing it. If we over fertilize and we have if we over fertilize and we have any type of stress, could be cold weather. Sometimes early in season here we have some cold spell, late winter cold spell, early spring, or could be drought. Then we could potentially accumulate nitrates, but we don't have any prussic acid problem.
Yes, correct. A lot of times when I think about nitrates and when they could accumulate, it's anything that really could inhibit the growth of the plant, so the plant's not able to utilize the nitrogen that it uptook. And so, like you said, that cold spell, especially our warm seasons, they don't like cold. So you get a cold spell, they're going to kind of stop growing really well. And so things that can basically inhibit that growth.
So if I have those two situations of high nitrogen and some stress inhibiting growth, what is the guideline to be able to consider that forage safe to graze again? How many days after?
So we typically recommend at least like 4 to 5 days after a drought breaking rain. And so allowing that plant to have time to utilize the nitrogen that it had uptaken and to basically be able to utilize it, make it into proteins instead of in that nitrate form that could be toxic to the animals.
So it's pretty quick also that it dilutes the nitrogen, because they grow so fast also.
Oh, they grow so fast. I think it surprised a lot of producers the first time they used it, of like, they turned around and it was already 2 feet taller.
Yeah, perfect. Then we're going to towards the end of the season, especially thinking about prussic acid. Well, nitrate accumulation too, if we have excessive nitrogen towards the end of the season. But then we have cold weather, short days. We can have drought, especially in Florida. We have a drought spell September, October, and that's when sometimes we use those annual forages, late planting of those annual forages, to be able to graze early fall, mid fall.
Yep.
And that's when we have some risk of the prussic acid mostly, right?
Yeah, as we start getting into those fall periods, cooler nights, and those frosts that kind of just come in and nip the leaves, that stress that frost can occur, causing that accumulation of basically prussic acid potential in that time frame.
In general here, we normally are not going to have a frost until probably mid-December, sometimes even later.
Sorry, I'm thinking of now for me, because I'm
No,
getting these calls
it is.
currently.
But it's important to talk, because we always have calls. It got a little cold. Okay, that's not a problem. But the problem is when we have that cell wall breaking of the frost. And also one thing that I don't know, I would like to understand a little better, is often that whenever we get a frost, is going to be very late in the season. And normally it's going to be at the end of the forage season. The forages are quite mature. So is it going to be a problem also on mature forage that's already, the sorghum that's already headed out, and it's at the end of the season, we have a frost? Is it still going to have accumulation of prussic acid there, or forming prussic acid there?
So I think there is the potential that you still could have that prussic acid being formed. I will say that there is kind of limited research on the maturity versus frost. So some of the past research has shown that it can cause basically a reoccurrence, and then others have said it basically doesn't respond as much because the plant's kind of done its job for the year. It's produced its seed, it's headed out. That's the goal of an annual. It's done its job. But yeah, I personally would be still cautious of something like that because of the reoccurrence. Sorghum also loves to tiller, and so you probably have some more tillers coming in and things like that. And so being aware and cautious is kind of the route I go in this case, because it is a stress response is kind of the theory behind it.
So if we are worried about either nitrate toxicity, prussic acid poisoning, what are the options we have to confirm or make sure we're safe on farm?
So if you want to do on-farm testing for prussic acid, the only one that I'm aware of is from Ward Laboratories in Nebraska. They have an on-farm test that they can send out. It gives you basically 3 levels: safe to graze, graze with caution, don't graze, is kind of the levels that it is assessing. And then you can also send them into like an accredited lab, get it tested directly for true prussic acid potential, and it'll give you probably a parts per million analysis, and it'll rank it on more of a more fine level in comparison to what the Ward Laboratory one does. It's based on a test where the paper turns blue, and how dark of blue it turns is how much prussic acid potential you have in that case. So it's a semi-quantitative analysis for the on-farm test. And then for nitrate testing, again, you can send that into the lab. The lab can give you a true parts per million analysis on that. There are some at-home kits that you can do, but they only go up to about like 500 parts per million, which really isn't dangerous yet. But it can give you an idea if you think it's like it is hot, that you get up to that point, then you send it in and make sure that you get a good analysis.
I don't think we have any of our agents that are equipped for that type of testing. So easiest way to do is sending it out to a commercial lab to make sure. And we have some very good commercial labs here that are going to turn around those samples pretty quickly.
And that's the true way to really know how much you have and what that danger is. And so I think sending it into those commercial labs is a really great opportunity.
Yes. And again, whenever if people are suspicious, testing and waiting a little bit, normally waiting a week or so, as you mentioned before, or cutting it for hay, you can eliminate some of that issue, unless it's very high.
Yeah. So I will say this was some of the research that I did during my PhD. When we cut it for hay, we actually did not see a reduction in prussic acid potential.
Okay, that's interesting. That's new. I thought the prussic acid would be easier to dissipate than nitrate.
So what we found is we were looking at Durin, how stable the compound that releases prussic acid, and Durin itself was very stable. We found that the compound that breaks down Durinase, was not stable, and it basically became inactive during that time. But then we tested the dried material in basically rumen fluid to see what would happen with the interaction with the rumen fluid to Durin, and it caused the release of prussic acid.
Oh, wow.
And so we saw that basically hay did not decrease during accumulation. Actually, our dried material seemed to be more stable than our fresh material.
Wow, interesting. I did not know that. Very, very interesting. And on the silage side, you have some reduction?
Silage side, I have not tested silage, but just the chopping action, the whole ensiling process and stuff, I could see how that would be declining. And most of the research that I've seen on the silage side, all of it basically showed some type of reduction, anywhere from 50 and sometimes up to 75%. And so on the prussic acid side, and so a lot more reduction there on that end.
Interesting. So I think we cover a lot. One of the things that I'm curious about, and again, a big disclaimer here: we're not vets, we're not recommending any treatment. But are there treatment for our cattle if we suspect one of those issues?
My recommendation is remove your cattle, remove it from the
very
feed.
Quickly.
Very, very quickly. A lot of the treatments, we just can't get to fast enough a lot of times. I would say call your vet, remove your cattle. There are treatments out there. I typically don't recommend them because we just don't have the time. And you just have to be on it very quickly. And so a lot of times, if you're introducing your animals to a sorghum field and you're concerned, make sure they're full. Don't let them out hungry so they're not just mowing down, because they can adapt some to the prussic acid or nitrates a little bit. So allowing slow introduction to that feed. And if you're really concerned, but you still want to feed it, you can always use a tester animal. Losing any animal is not ideal, but losing one over your whole herd is a better option.
Much better. Yes.
Yes.
Now, ideally, we'll would not get to that point. There's an alternative for farmers. Yes, and that's another thing to emphasize so much about hay testing. It's so easy to get a hay test, and you can get all those numbers there. You can get nitrate concentration, you can get protein, you can get digestibility, saves your animals, help you balance that diet much better.
Yes, I agree so much. It's the baseline. You can starting to separate with that nutritive analysis, what animals should be fed what hay, the safety of it, everything. It's probably one of the best cost-saving things you could do.
That is true. Shelby, anything else we forgot to bring to the audience that is important about the topic of nitrate toxicity and prussic acid poisoning?
I think it's just knowing that it's there, but also not being afraid of it. I get a lot of producers that are very afraid of it and decide to go with something else. These are great forage species to be able to utilize. It's just being cautious and being aware.
Yes, one of our colleagues here, Dr. Q, always would say, I've seen more cattle going hungry because of fear of bloat than not planting clovers because of the fear of bloat than because of the bloat itself.
Yes.
Okay, well, I really appreciate your presence in our podcast today. A lot of wealth and help guiding us through this problem. What are those two problems that are different? What are the management strategies, and how can we know what to do with those forages? Thanks a lot. And for those folks that have more interest in our podcast, take a look at the previous episodes where we cover many topics about forage and livestock production in the Southeast and beyond. And also contact your local extension agent. We're here to help you. And our local agent is going to be the quickest way to get assistance from our extension system at the university. Thanks so much, and I hope to see you in the next podcast. This podcast was brought to you by the University of Florida Forage Team with technical support from the University of Florida College of Agriculture and Life Sciences, Faculty Instructional Resource and Support Team. This episode was produced by Marcelo Wallau, Olivia Mowley, and Ashley Kanabrowski. We hope you have enjoyed this podcast. If you have any comments or thoughts to share with us, please reach out to us through our email, forages@ifas.ufl.edu, and find us on our social media, uf.forages on Instagram, UF Forage Team on Facebook, or UF IFAS Forages on YouTube. We hope to see you in our next episode.